Welcome to Strength in Concrete, the podcast presented by the Post-Tensioning Institute, recognized as the leading authority in advancing the post-tensioning industry. In today's episode, PTI Engineer Brandon Harman chats with past President Harley Nethken about the benefits of post-tensioned sport courts. From tennis and pickleball to basketball and running tracks, you will discover how PT technology is transforming court construction. Harley explains how PT pre-compressed concrete combats temperature changes, soil movement, and flexural stresses. This creates a durable, long-lasting base with minimal joints. You will learn why PT courts are highly efficient. They are thinner, usually around 4 and 5 inches, compared to more than 6 inches for conventional concrete. They also use less steel and outperform standard asphalt courts in longevity. The conversation dives into key PTI resources to help guide your next project. Brandon and Harley cover DC 10.1, design of post-tension slabs on ground, and DC 10.3, design, construction, and maintenance of post-tension concrete courts. They also share finishing tips from the U.S. Tennis Court and Track Builders Association. Finally, Harley highlights the three-legged stool for success: sound design, PTI-certified plants with traceability, and certified field personnel. Whether you are a sports enthusiast, engineer, or construction professional, this episode delivers valuable insights. Let's join their conversation.
Welcome to another podcast here at the World of Concrete by the Post-Tensioning Institute. My name is Brandon Harman. I'm a PTI engineer. I joined the Post-Tensioning Institute a couple of years ago after spending about 10 years as a structural design consultant. This podcast today, we're going to be talking about post-tension sport courts, and I can't think of a better person to join us today than this handsome young gentleman to my right, Mr. Harley Nethken. He's a PTI past president, PTI fellow. Harley, you want to introduce yourself?
Thank you, Brandon. I appreciate that. We'll negotiate the handsome part later. No, I've been here in PTI since late 80s. We are a post-tension manufacturing operation. I'm licensed in various number of states. We've designed pretty much everything from slab-on-ground to elevated structures. Yeah, we've been doing a lot, and the sport court world has come alive in the last 5 to 10 years. It's really become a very state-of-the-art method to build a court.
Yeah, so sport courts, so tennis courts, pickleball courts, all of the above. Basketball courts.
Basketball, tennis, running tracks, padel, all the new outdoor activities that Americans are participating in, the Get Healthy movement.
Sure. So for sport courts, in terms of post-tensioning, so how is a PT sport court advantageous when it comes to long-term durability in terms of lower maintenance costs, sustainability, etc.?
The principle of a sport court for post-tensioning is the tendons pre-compress the concrete or provide a compression in the concrete to give it the strength that it needs to resist the flexural stresses due to temperature differential, potential soil movement, and it gives the concrete a very stable, it allows the concrete to provide a very stable base for the coatings. Very unsusceptible to the ground movements, thermal movements. It just is a lot more stable, and it has a very long life. I don't want to say unlimited, but we haven't had one just fall apart yet like asphalt does.
So in terms of durability, so with the post-tensioning, compressing that concrete, you can also add a little bit of partial pre-stress, but less joints helps control cracking, and in the end, it results in long-term durability.
The joints are virtually eliminated. In a parking lot, or in an industrial slab that's conventionally reinforced or plain concrete, your joints will be 12, 15, maybe 20 feet on center. In post-tension sport courts, a 60 by 60 joint pattern is very common, very typical. We can put the joints between courts, and we can place the joints under the net line where they're least objectionable. And I don't want to say a joint-free surface because they're there, but it's in places that doesn't affect the play.
Yeah, so long-term durable surface. There's obviously a lot of other options out there that you can build a sport court out of. But what are the key structural performance advantages of a PT sport court versus, say, like an asphalt or a conventionally reinforced concrete court?
Into a conventionally reinforced concrete court, The PT court is usually thinner, at least 4 inches. We typically work within the 4.5-inch range for a couple of reasons, and maybe a 5. But the equivalent conventional court would be in the 6+ range. The amount of rebar in a conventional court is fairly significant compared to a post-tension court, where the tendons can be 4 foot on center to maybe as low as 2'6", depending on the length of the court. So there's a lot less steel. It's an active reinforcement instead of a passive reinforcement. Rebar, the concrete has to crack, the concrete has to deform in order for the rebar to resist that movement. In a post-tension court, the compressive stress is placed on the concrete within hours of it being cast. So the concrete loves compression. We put it in compression day one so that any of the temperature differentials that it experiences or any of the tensile stresses that it experiences have to overcome that pre-compression that we've already put in it, as opposed to the rebar going into development. As to an asphalt, with the chemicals that they're now using, the chemicals that are now banned, the availability of the chemicals that we have to make asphalt, the life expectancy of an asphalt court is significantly shorter than a concrete post-tension quarry.
Okay. So in other words, for a mild reinforced concrete court, an equivalent PT court would be, to achieve a similar structural result, a PT court would be thinner than a reinforced concrete court by a few inches.
Absolutely, yeah. 6 or 7 inch conventionally reinforced concrete court would be 4.5 inches thick. Now, as you get into a non-professional court or kind of a backyard court where somebody would put a 4-inch down, that's hard to say we're going to save concrete because of the minimum thickness of a PT court is 4 inches.
Right.
Minimum thickness. So anything up, our minimum are 4, but very rarely do we go anything over 5.
Yeah, just for tolerances and just construction and placement and
get tolerances and workability and just common sense of how the concrete's placed.
Sure. So for a structural engineer tasked with, say, designing a sport court with post-tensioning in lieu of other alternatives, what are some of the resources available and what's a good place to start? I know we have our DC 10.3 publication. You could talk a little bit about that and some other good resources, and just how do you get started designing one of these PT concrete courts?
PTI is your gateway to the information. The Design Committee 10, which is a slab-on-grade committee, document.1 deals with slab-subgrade interaction. That's a very good document for how does the soil-slab interface actually happen. Shrink swell clays, compressible, we don't call them compressible, settlement-sensitive soils, and stable soils. It deals with that interface of the concrete to the soils and the effect of moisture on the soil. Is it a positive swelling or a shrinking? Edge lift or edge drop, I think we're calling it now. So DC 10.1 gives you the background of soil-slab interaction. DC 10.3 focuses on sport courts, spacing, common sense application for the installers in the field, some safety guidelines, minimum requirements of pre-compression that are recommended, minimum thickness, how to handle the edge of the slab and the interface of the fence post or the net post, dealing with detailing issues due to the naturally occurring shrinkage to give it a good, minimally cracked surface. So DC 10.3 focuses on the functionality of the tennis court or the sport court. DC 10.1 gives the designer the information of the soil-slab interface.
Okay. Those two publications are available on the PTI website, but aside from those two, are there any other publications that you can think of that would be helpful in helping a new engineer out designing one of these?
Yeah, there's another association, U.S. Tennis Court Track Builders Association. They have a document out that is not as technical on the post-tensioning, but it is a good resource for just general overall concrete placement, handling of the concrete, making sure that the concrete is compatible with the final surface, the finishing, is it a broom finish, is it a bead blasted finish? They have a lot of information on the final finishing of the concrete for the applicability of the sport court.
Okay. And I know we recently the American Sports Builders Association had their technical meeting at the end of last year, but I know they've got a few good resources in terms of just some general detailing, best practices, and things like that for post-tension concrete courts that can be of some assistance as well. For PT sport courts, do you have any good case studies or anything you've worked on that's provided benefits to owners and developers as well as design and construction team for like a post-tension concrete court, whether that be tennis court, pickleball court, any of the above?
The sooner we get brought into a project as an engineer, the better. There's a lot of wise tales. There's a lot of misnomers out there that owners who are not knowledgeable in the technicals of concrete placement and reinforcing. So the sooner a post-tension expert can be brought in to kind of level the playing field of discussion, to keep it on focus and on track, really helps. Working with the architect or the planner, the designer of the facility to limit the size of the courts, to make sure they're functional and practical to meet the owner's need early on is very helpful too. There are some limits to the size of the courts we can put down. So as long as that's incorporated in the master plan of the system, that helps. Working with the concrete supplier to make sure that they have a mixed design that can be placed and finished to meet the surfaces of the coating material. And then being able to consult with the coating manufacturers. There's a infinite number of products out there just to make sure that they have a compatible product with the final concrete that we're going to be building.
Yeah, because that's a big part of especially pickleball and tennis courts, the final playing surface and making sure that everything is compatible and for long-term maintenance. I know that you've mentioned it a few times, but you've mentioned that you worked on a project at the White House. Was that recently, or is that?
The White House U.S. Tennis Court Track Builders Association, before it was morphed into that name, I believe it was in the Obama administration, a post-tension court was built. I don't know the history behind it. I know there was some discussion, and it was built, and it had gone through, and as various presidents come in, sometimes it's very active, sometimes it's not used a lot, depending on the administration. And about 7 years ago, the administration wanted to add a viewing center to the court, bring dignitaries in and have it as a viewing area for them. It was a fairly rudimentary court to begin with. They had a little place for a picnic table, but they wanted to build a nice structure next to it. And I got to go up there, and it was just awe-inspiring to be in the White House, to see the history, the artwork, the pictures of the president. It was very humbling to see how great that structure and the history behind it. But it was about a 20-year-old court and performing beautifully, just really minimal amount of maintenance. As presidents come and go, different things get different focuses. So it had been over in the corner just doing its job, and it looked great. Joke is that I was standing around with a can of spray paint marking the tendons with a GPR, ground penetrating radar, to where they knew how to demo certain areas of it. And there were 4 or 5. There was a Secret Service guy and some groundskeepers. And I have a picture of myself with a can of spray paint painting this court. So I think I'm probably one of the few guys that has tagged or graffitied a White House property without being arrested. But that was one of the highlights of my career, is just working on that project. And we helped and consulted. I'm not really sure what the final deposition of the tendon replacement removal was, but apparently it got built and recoded, and it's back in operation again. So it's a
cool project, a story that not many people can say that they've been able to do, but that is a testament.
It was great. And I tell you, the White House is great. It is a great representation of our history, the legacy of all the artwork and all the president's rooms. It is.
Yeah, that's cool.
Everybody needs to visit it and get a little history. But it was great.
It's also a testament to the post-tension court 20 years later. It's actually being able to see something that's been in service that long and still performing very well.
Admirably. We are starting to get callbacks now on renovation, remodeling, courts that we never knew existed. Again, 20, 25, 30 years old, that were built correctly and are performing very well. With today's technology of identifying cables with GPR, we're able to go in there and make very safe remediations and recommendations. But with the longevity of it, we're also seeing a couple of courts that are performing poorly because of improper labor, improper stressing, poor quality control. So PTI certification, getting the labor to come in and understand what's important, to understand in the design, the cover requirements, proper stressing, proper consolidation of the concrete. As we've matured as an industry, the importance of certification is now showing its light. If it's done, it works great. If it's done wrong, it's like anything else. It's going to be miserable.
That's with anything. If it's not done well to begin with by certified personnel, then it won't perform. But I want to expand on that a little bit. Can you highlight, we've got our level 1 and 2 Slab-on-Ground certification course. Can you highlight how that workshop can be advantageous as an educational opportunity for not just contractors, but even consultants and engineers?
I'm going to take it one step further.
Okay.
Let's start with engineers that have gone through the books and the design, the PTI publications. It looks great on paper. So they get a contractor, and the contractor needs to purchase the post-tensioning material. It needs to come from a PTI-certified plant.
Thank you for reminding me. That's the first step from a
That's the love of my heart. The PTI plant certification program ensures that the manufacturer of the product has traceability. It doesn't ensure the product itself, or it doesn't certify the product. It certifies the process. As a manufacturer of the tendons, I put the proper amount of plastic on the cable. I have the proper grease. I have the proper amount of PT coating on the cable for the corrosion protection. Then, as the strand is built in bundles, I know where everything comes from. I have traceability of all the components of every individual job back to their original source. And the original source has all the necessary testing, the 1,000-hour tests, the static and dynamic testing of the anchors and wedge systems. The encapsulated systems have to meet a watertight test to make sure that they're doing what they are proponents to propose to do. Then you go into the design. PTI documents come in with DC 10.1, which talk about the soils. We talked about that. DC 10.3, which talks about the design of the sport court itself. There are any number of other PTI documents that have intellectual overlap into what we're trying to do. Elevated structures, those concerns, anchor forces, bursting steel, all of that kind of comes into it. So now you have a great design. Again, plant certified, that starts there. Then the personnel certification is for the actual individual labor force in the field, that they understand how to handle the cable, how to unload the cable correctly, how to not damage the coating, the extrusion, and handle everything correctly. If it is damaged in transport or in unloading, how to handle the repair process to make sure it maintains its integrity. The level 1 and level 2 terminology is important. They can call in if they have a question, and they can discuss the problem with the designer and the fabricator to resolve anything that can happen in the field. We're pulling 33,000 pounds on a piece of cable with hydraulic porta-packs, and sometimes things go wrong. So you need to make sure your personnel are certified to set everything up correctly, to know what to look for, to not set up a hazardous situation. Things happen, but having people know what they're doing, stand clear, be aware of these pressures, and concrete ruptures instantly. It doesn't yield and break. It cracks and goes.
Yeah, it's
brittle failure.
Yeah.
So having that knowledge and being aware of what can happen is very important to a successful project.
Yeah, it's like the analogy I've heard is it's like the three-legged stool, having good drawings and specifications that are informed by our publications and a good design is one leg of the stool. Having materials that are from a certified plant known as good quality materials that are going to perform the way that the design was intended is the second leg of the stool.
Right.
And then the third leg is certified personnel installing that certified material so that, again, that certified material is installed in a way that will perform long term. And if any one of those legs of that three-legged stool is off, it may not perform the way it was intended.
Yeah, it can be. It can be not.
So besides traditional sport courts like tennis ball or tennis, pickleball, basketball, what are some other types of sport-related PT slab-on-grounds, and how does PT benefit those?
The first one you mentioned, the tennis, we're seeing a lot of post-tension overlay of existing tennis courts that are not performing well. So tennis is still very popular. The onset of pickleball is, we all know, it's taken over the world right now.
Yes.
Everybody and his brother's playing it. They're resurfacing concrete courts that have been lined out for tennis. They're repurposing them for pickleball. 20 years later, what was popular then is being repurposed, so they still have the life cycle on that. Basketball courts, we're seeing a lot of asphalt courts being abandoned and then go to concrete.
Now that's an overlay over top of asphalt?
Overlay on top of the asphalt. We're seeing a lot of tennis courts overlay asphalt courts. The new game on town, I'm hearing about it, I'm not familiar with it at all, is padel.
Okay.
And it's an outdoor game of racquetball, as I understand it. There's a glass wall around the court, and the player can play the ball off the wall as well, which requires a fairly substantial post to handle the glass wall and the impact loads. As opposed to a sport court where there's virtually no load on it at all except for the net post, which is in the middle of the slab, these glass walls through the concrete, through the metal column or the steel post or whatever it is, can generate moment shear at the column base. So we have to integrate that part of the design into the sport court itself. A little bit of coordination, it's not that hard to do. Make sure that when they epoxy or retrofit the bolts for the base plate, because they have to be dead on accurate to handle this glass wall system, that the tendons are not in that vicinity. So a coordination between the design and the final use, it's becoming very popular with the padel market. Again, they have a playing surface that's very nice, lasts a long time, and we can incorporate their column reactions.
Sure. Yeah, knowing where they're at, and it's not hard to coordinate those tendons around that and still provide a high-quality surface for the padel.
Absolutely. Absolutely.
Do you see any other future trends noted in sport courts or specific to PT sport courts that's upcoming?
We're seeing more and more running tracks becoming designed post-tension. There's some technical challenges in that. World of concrete, huh? It's noisy in here. Running tracks are becoming more and more popular. Again, they're virtually a lifetime in structure. I expect to see more and more of that in the future. Very stable. We've got some, I think, Dick Martyr, 40 years ago, developed a running track design. I think it's been built up in Denver area, and I haven't seen it, but there's been conversation that it's still performing 40, 50 years old.
Wow.
So it is coming. The capital investment is a little more upfront, but the longevity is worth the rate. The rate of return is much better on.
Right, because the maintenance schedule is much better.
Much better. Whatever the coating or however you paint it and stripe it for whatever sport is popular today.
Harley, I appreciate your time today and joining us. Thank you,
Brandon. Appreciate it. Take care.
Thank you.
Thank you for joining us today on Strength in Concrete, brought to you by the Post-Tensioning Institute. We hope today's discussion provided you with valuable perspectives on the advancements and opportunities shaping our field. If you would like to deepen your knowledge or explore additional resources, we invite you to visit our website at www.post-tensioning.org. If you enjoyed this episode, be sure to subscribe to Strengthen Concrete on your favorite podcast platform and enable notifications so you never miss an update. Until next time, this is Strengthen Concrete, your trusted source for post-tensioning expertise. We look forward to connecting with you next time.